re-recordings for this course because this stupid thing doesn't always work. So I will try to re-record those lectures this weekend. All right, so in the last, well, I guess in the lecture from Monday, we were talking about if statements, and we got to this point here. So this is a script that compares there's supposed to be two integers that come in from the command line and test whether or not, tests the order of the two integers, right? Whether or not the first integer is less than, greater than, or equal to the other integer. So it's like Java's compare to. So the first command line argument is I1, the second command line argument is I2, right? And I was telling you about the integer arithmetic comparison operators, right? If you're using square brackets, then not equals to is hyphen NE, right? Which is awful to write, but that's the way it is, right? So the reason it looks like this is because less than and greater than inside of double square brackets, those are the string comparison operators. Right? So if I1 is not equal to I2, right, and I1 is less than I2, right, then we're going to print out -1, right? Otherwise we're going to print 1 because I2 is greater than I1, right? And otherwise we'll print out 0 because they're equal, right? And if you run that, you get 0 because 5 and 5 are equal, right? -3 is less than 12, so you get -1. 22 is greater than 21, so you get 1. And the thing that you have to remember is that if the values stored in the variables are not actually integers, so they're actually strings instead, so hello and goodbye, then as far as bash is concerned, their numeric value is simply 0. Right? And so if you compare hello and goodbye, you get 0. Right? A, B, C, and 3, oh, so they're equal. Right? So bash thinks that these two values are numerically equal. Right? It thinks that ABC is less than 3 because ABC is 0 as far as bash is concerned. And XYZ, 12 is greater than XYZ because, again, XYZ is 0. Right? You get 1. It gets slightly worse because bash lets you write numbers or integer values down in using a different base. So you can write in base 2 or base 8 or 16 or whatever base you want. The syntax is funny. So it's 2 and then number, so that's base 2. So that indicates that the remaining digits are a binary number. Right? And so this is the binary number 101, which is, what is it, 6? 5, it's 5. Right? So that actually works. Right? Is 5 greater than 1? Yes, it's greater than 1. The problem is that the rules bash uses to parse this value here, this, come on. Why is my, so the rules that bash uses to parse that value there and interpret that thing in a different base is funny, right? So here, if you write 2ABC, right, bash doesn't treat that as a string, right? It says, oh, you want this number in base 2. And then it tries to convert, or some other base, sorry, and then it tries to convert the ABC into that other base. And when it does that, now it fails, right? So it says 2ABC, value too great for base, right? Which, if you don't know that you can write numbers in a different base, looks really weird, right? But bash doesn't treat that as a string anymore. It's trying to treat it as looks like a base, some base number, not necessarily base 2, because it's missing the pound sign. So you get all sorts of strange behavior that happens. Really what you want in this script is to actually test, is the value an integer or not? But we don't know how to do that yet. So we have to wait until, I guess, the next lecture? Sorry, oh, did it go out? It says it's presenting. So I'm plugged in here. I guess it could be here. That is the right. Sorry, it looks like we're not going to be able to get the right projector going today. Everything's plugged in as far as I can tell. So if you're sitting over there, sorry, you got to read this, this monitor. All right, it was working, right?
It was.
Yeah, it was working. So I don't know what's going on. Okay, testing for the correct number of command line arguments. All right, so bash doesn't, so if you write a script and it's expecting, say, 3 command line arguments, and you only give it 1, then as far as bash is concerned, the second and third command line arguments, if you try to use them, you just get the empty string. Right, so you don't get an error to indicate that you have the wrong number of command line arguments. Right, so if your script requires a specific number of command line arguments, then you have to test for it. Right, so again, I'm going to use the integer numeric comparison operators here, so minus -ne for not equals. Right, so our named shell script requires you to give it a new name, sorry, if it's not equal to 1, yes, requires you to give it a new one name for the script to create as a command line argument. Right, so it actually checks, is the number of command line arguments not equal to 1? Right, if that's the case, then it outputs an error message. Okay, now this one is testing whether or not the file exists, right? So minus $1, does the file exist, right? If it doesn't exist, if it already exists, then it complains, it says that script already exists, I don't want to overwrite it, exits with an error, right? And finally, if it gets to this point here, you have the right number of command line arguments, the file does not already exist, so it goes ahead and creates it using a redirection. Right? And then it changes the permissions on that file. Right? I really should go in and fix this script sometime. Sorry. Because this is going to mislead some of you. All right, so inside double square brackets, I don't have to quote the $1. Right? So $1's a file name. If it has some unusual characters in it, everything's fine in this case. Right? Inside double square brackets, the file name expansion and word splitting doesn't happen. So weird file names won't affect that comparison. Down here, it will. Right? So if there is a strange character in the file name, like a star or a question mark or square brackets or spaces, right? When you go to redirect the string, the hashtag bin bash to the file, the redirection will fail or may fail, right? So you have to quote that use of the positional parameter number 1 in order to prevent any weird things from happening because of unusual characters. Similarly here, when you change the permissions on that file, again, it's a file name. If it has any strange characters in it, expansion will happen, and you'll end up passing in the wrong file name to chmod, right? So again, that really needs to be quoted. Right? So that has to be quoted there. Inside double square brackets, quoting is not necessary. But you can quote if you want, at least with the file comparison operators. All right, so that's, you now know how to write an if statement. What you don't know how to do is how to combine conditions. So there's a very short notebook called Conditional Operators that tells you how to combine various conditions. The syntax is a little bit funny compared to what you're used to writing in Python and Java, right? But it's not too bad. All right, so if you want to use so you can always use round brackets around a conditional expression, and that just controls the precedence, right? So if you put round brackets around a conditional expression, that just means evaluate this expression first, right? If you want to negate the value of a conditional expression, it's exclamation mark. Space, the space is important, right? Exclamation mark, space, followed by the expression, right? If expression is true, that thing becomes false. If expression is false, that thing becomes true, right? And looks like Java's and or looks like Java's or. Right? So, does a file not exist, right? So -e tests if that file exists, right? If I want to know that it doesn't exist, well, just negate it, right? So exclamation mark space, -e space $file, right? If you want to, you can put the exclamation mark in front here, like that, They both do the same thing, right? Or they both result in the same thing. They actually do something different, but they both result in the same result. They both produce the same result. Right? So let me put it back to the way it was. Right? So if the file doesn't exist, it's going to create the file using touch. Right? If the file does exist, it'll print out the file already exists and does nothing. I don't know if the file exists or not. Okay, so I guess it doesn't exist. Right? Now it exists. If I run it again, it says that that file already exists. It doesn't make the file again. Right? So there's not. When you're testing for files, often you want to test whether or not just if they're readable or writable or executable, right? You also want to know, is it a regular file, right? So, or is it a directory, right? You might want to go into the directory, you might want to do something with the regular file. Right? So I have a file apparently called not readable, and I'm going to remove read access on that file for everybody. Right, so A minus R, take away read permissions for everybody on that file. Right. Okay, I have a different file called readable, so that one presumably is readable. Right. So if the thing stored in file, is that a regular file, right? And is it readable, right? Then it's going to print file as a regular file and is readable. Right? Otherwise, it's going to print file as not a regular file and or it's not readable. So readable is a file. Sorry, readable is a regular, readable is a regular file. That's better. And readable by me. Right? If I change file to the not readable one, right, we get not readable is not a regular file and or not readable by me. Right? And so there's and. Notice that the condition is that. Which again looks weird from for any modern programming language, right? But that's the way you write it in Bash. And similarly, the second condition is that. Right? The way that AND works is that, if that is false, then that is never evaluated, right? Because false and anything is always false, right? So this short circuit AND. And finally, the leap year example. Right, so you can test if a year is a leap year. So a year is a leap year if it's divisible by 400, or if it's divisible by 4 but not divisible by 100. Right, so is it divisible by 400? Right, so take the remainder after dividing by 400 and test and compare to 0. Right, is it divisible by 4? So there's the is it divisible by 4 part. Right, and not divisible by 100, right? And so there is the and not divisible by 100 part. Right? So that one uses round brackets, so there and there. Right? So for precedence, right, it uses and here and it uses or there. Right? And again, we're in double round brackets because this is a numeric comparison, and it's easier to write the numeric comparison this way than it is to use minus NE for not equals and minus EQ for equals. Right? And so the conditional operators work more or less the way you expect them to behave. You just have to remember that some of the conditions look funny in Bash, right? Like that, for example. All right, any questions on writing if statements? Okay, so the next thing I want to talk about is this command called tr. And so this thing is useful when you're dealing with strings. And the simple string, the string substitutions that I taught you about in parameter substitution, they aren't sufficient for your purposes. So tr is a standalone command. It is short for translate. So it will translate from one character, it'll translate characters from one set to another set. Right? So for example, you can translate all the lowercase letters to uppercase or vice versa or something like that. But it does more than that. Right? It also squeezes. So squeeze means remove duplicate, a sequence of duplicate characters, right? And it will delete characters from a sequence. Right? And delete characters. And delete characters from standard. So it reads from standard input and it writes to standard output. Right? So it's similar to doing a character by character search on a string, and then replacing characters as you find them. So it does three things, which means there are three ways to use this command. So it's a little bit, you have to make sure that you keep the usage of the command straight. So when you're trying to substitute, make sure you're using substitution and not deletion. Right. So the command name is tr. It has a bunch of options that you can use. Right. You always pass in at least one string. That string is normally a set of characters. Right. So normally there's no duplicates in that set. Right? And then you pass in an optional second set of characters. Right? Again, it's a set, or is supposed to be a set. Right? Whether or not you pass in the second set depends on whether you're trying to translate, squeeze, or delete. Right? So if you pass in sequence 1 and sequence 2, or set 1 and set 2, you're doing translation. Right? Okay, so here is my use of tr. Right? So tr reads from standard input. Right? So in other words, the idea is that you run tr like this from the command line. Right? So if I ran tr from the command line like that and press enter, it's going to expect you to enter in a string, puppy, right? And then it performs the translation. Right? So every p gets translated to t. Right? So puppy becomes tutty. Right? And you can do this again. Right? So porpoise, right? And that becomes tortoise, right? Control D will stop, right? End standard input. Now normally, so if you're writing a script, you probably don't want to use tr this way. You've probably got a variable somewhere where you've stored the string that you want to translate, and now you would like to pass it to tr, right? So one way to do this is with a pipeline, right? So I can print the contents of the string x. So here I'm using printf. You can use echo. It'll do the same thing in this example. Right? I'm going to use the printf command. Printf you're going to see when we talk about C in more detail. This just says print the string x, treating it as though it were a string. Right? You can also print something treating it as it were an integer or as a floating point number or something like that. Right? %s means string. That's the thing that you want to print. Right. That'll print something to standard output, which gets redirected to the input, standard input of tr. Right. And so if I convert all the p's to t's, you get starring with a turtle tortoise. Right. If you've done assignment 2, you know that you can use a here string instead. Right. So instead of using echo or print and a pipeline, right, I can use tr directly, like that, and then use a here string. Right. So the triple less than $x. Again, I have to quote $x because it's got spaces in it. Right? Press enter. Oops, sorry. Run the script again. Right? And it prints out the exact same thing. Right? So use a pipeline. Print the string, you pipe the output to the input of tr, or use the here string to grab the contents from a string directly. Right? Both are fine in this case. You can, so this set P, you can replace, doesn't have to be of length 1, right? So for example, if I wanted to replace all of the I's, I guess, with something else, so I'll replace the I's with O's. I have no idea what this is going to do, right? We get, well, I can't say that, but anyway, you get that instead, right? So every P gets replaced with a T, every I gets replaced with an O, and so on and so on and so on. If you want to, here, that's a Java package name, right? If you wanted to get the directory corresponding to the packages, you replace every period with a /, right? So again, we can use tr to replace every period, with a /, right? And that tells you that the directory of the sys124 package is ca queens u cs sys124. So when you specify the sets sequence 1 and sequence 2, there are multiple ways to do it. You can just put in the strings as plain old strings, right? So set 1 is some string, set 2 is some string, right? So here I've got a set of all the uppercase English letters, right? That gets a bit tedious to write. So in GNU Bash, you can write a range. So A-Z gives you the range capital A through capital Z, right? If you want to, you can use the POSIX character classes. So you go look those up if you forget what they are, right? The uppercase letters are square bracket, colon, upper, colon, square bracket. When you're translating, normally you want to translate n different characters to n other characters, right? So the size of both sets should be the same. So here I want to replace all the lowercase letters with uppercase letters, right? So I want to replace all lowercase a through z with capital A through Z, right? So sequence 1 are the lowercase letters, sequence 2 are the uppercase letters, right? So little cis 220 becomes big cis 220, right? Again, each letter gets translated character by character. Right. Okay, so if your first set, so if sequence 1 is shorter than sequence 2, everything works the way you expect, right? So you have more characters in the second set, the extra characters are just ignored. So here I have the sequence A through Z followed by 0 through 9, right? So there are 36 characters here, there's only 26, here. Right? So everything works the way you expect it to. It still converts big cis 220, Oh, wrong. Why did I call it from and to? Sequence 1, and sequence 2. Right, so it still converts lowercase to uppercase. Okay, now you run into a problem if the first sequence is is longer than the second sequence, right? Because there are characters in the first sequence where there is no corresponding translation. And so what you get depends on the version of TR that you're running, right? So if sequence 1 is longer than sequence 2, then GNU TR extends sequence 2 by copying the last character until they're the same length. Right? So here we've got sequence 2 is X, right? Sequence 1 is the digits 0 through 9, right? So 0 gets converted to X for sure. What 1, 2, 3 through 9 get converted to is unspecified here, right? So anything could happen here. In GNU Bash, or GNU TR, that X, you just end up with 10 of them. So it just duplicates the X for every character that's in the first sequence. So this replaces all digits with the big X, like that. Right. That's not portable. Right. If you want to do this in a portable way, you have to use, again, some strange syntax. Right. So you make a character class, right? So square brackets, and then you put a star in. So the star automatically duplicates this character class so that it has the same length. There. So X star inside square brackets means duplicate X as many times as required, right? So now this is the portable way to do it, right? So that's guaranteed to work. Back here, the range is also not portable. GNU TR supports the range, but not all versions of TR support the range. Okay, what happens if you have duplicated characters, right? So these are supposed to be sets, right? So in other words, they're not supposed to contain duplicate characters. Right. Here, I've got the I have the non-set little c, is, little c, right? So c is duplicated twice. The second sequence, I have capital CIS, right? And so if you try to translate CISC 220 using these two sequences, it's not clear what's going to happen, right? It kind of looks like little c becomes big C, right? Little I becomes big I, little s becomes big S, right? And then you would think that it just ignores that C, that duplicate. It's not what happens, right? Instead, what happens is this second string gets extended, so it becomes CISS, right? And then it maps the C to the capital S, so you get big SISS, right? It doesn't do what you want it to do. So when you're doing translation, the normal thing to do is to make sure both strings have the same length, right? And there are no duplicates. Okay, if you want to delete characters, then you only pass in one set, right? So you pass in one of the two sets. Why did I call this sequence 2? Sorry. Sequence 1. There we go. Right. Okay, so if you want to delete characters from a sequence, from a string, you pass in a set of characters that you want to delete, right? And you use the -d option, right? So that tells TR to remove all the characters in sequence 1. So remove all the hyphens, right? So that removes all the hyphens, right? You can remove all the hyphens and the 2s, right? Just extend sequence 1. Oops. Hey, that's good that happened. That looks like an option now when you pass it to when you pass it to TR. So you probably have to write that as 2-. There you go. Right, so when you have the hyphen in front, the hyphen shows up here as -2, right? That looks like a second option. -2 is not a valid option for TR, right? And so you have to change the order of the 2 and the hyphen. There's probably another way to do this. I guess the other way to do this would be like that. Yeah, oh, no, that doesn't work either. Never mind. I was wrong. There probably is another way to do this. I don't know what it is off the top of my head. That one does work though. So as long as the hyphen's not the first character, it won't try to, as long as it's the last character, it will interpret the hyphen correctly. Right, notice what happens if you also try to delete the zeros. Right, now it barfs, because now it thinks this is a range. So you have to be a little bit careful with the hyphen. All right, and finally, if you want to replace runs of repeated characters, then you can use the -s, right? So here I'm going to use -s to replace the multiple spaces that are all beside one another with a single space, right? So this is called squeezing, right? Repeated sequences of a character all get reduced down to a single instance of that character, right? So if I squeeze that string x, right, I get A space BCD, right? So it removes all sequences of repeated characters. Right. If I'd like to remove the repeated B's as well, right, just stick in a B into your sequence, right, and that removes all repeated instances of the B. And finally, you combine all these things together. So you can squeeze and delete at the same time, right? If you do that, deletion happens first, and then the squeezing happens second. And so if you want to, you can create a little example down here and try it out. Right? So there's the TR command, occasionally useful for replacing or for substituting characters from one string into another. One of the assignment questions has you use TR, right, to do some simple substitutions. All right, okay, we're moving along at a good pace. There's regular expressions. All right, so the next notebook is the regular expression notebook. So this is more string stuff. All right, so anybody used a regular expression before in here? Yes, a few, okay. So I'm going to start with a quote, right? Some people, when confronted with a problem, think, I know, I'll use a regular expression. Now you have two problems, right? So regular expressions are themselves a language. Right? So you're now about to use a language inside of another language. Regular expressions are very commonly used in programming in general, right? So especially when you're validating stuff. So if you're doing any web application and you have to validate user input, often some kind of regular expression is used to validate the user input. So a regular expression, or regex for short, basically lets you describe a pattern of text. Right? Now, you also have the simple patterns that bash gives you, right? So star match any sequence of characters, right? Question mark match any single character, right? Regular expressions and the bash file name and the bash wildcard matching are completely different, right? So if you're doing wildcard matching, remember you're doing wildcard matching, right? You've got star, question mark, and square brackets. They mean something very specific. If you're doing a regular expression match, the same characters are used again in regular expressions, but they mean something completely different, So don't confuse the two, right? Don't mix the two. Many languages have support for regular expressions, right? So Java's string class has methods that support regular expressions. Python has regular expression built into it, regular expression matching built into it as a module. I think the module is RE. Languages like JavaScript and many of the web programming languages, they all have regular expression handling built into them. Right? Now, the idea behind regular expressions actually comes from theoretical computer science. So you have to take some theory courses in your computing science education, right? A lot of the theoretical courses, many students don't like them, but some very important ideas have come out of them, right? And so regular expressions is one of these ideas, and they're used everywhere. So they come out from the formal language theory. So how do you specify or how do you describe a computer language? Right? And so the idea of a regular expression came from there. Right? Now there's many flavors of regular expressions. Bash uses what's called the POSIX extended regular expression syntax. Other programming languages use a different version of regular expressions. So if you're searching for help on regular expressions, make sure you match the language to the regular expression language, right? The syntax is slightly different between all of the regular expression languages. Okay, so there's no way that I can tell you everything about regular expressions, right? This would basically be an entire course, more or less. If you want to know more, go to the bottom of the page, and there are some links to pages that talk about regular expressions in detail. They are extremely powerful. They are very hard to use correctly, but they are very important as well. So we're going to use the basic regular expressions in Bash. We're not going to try to come up with anything very complicated. Okay, so a regular expression lets you determine whether or not a string matches a pattern. Right? So typically you want to use this as a condition. Right? If you want to do a regular expression match in Bash, you use the double square brackets. Right? The syntax is, right, there's your string. Right? On the right-hand side is another string that describes the regular expression, the pattern that you're trying to match. The operator is equals tilde. Right? So that's the one you should be using. Right? So equals tilde. So if that string matches that regular expression, then this will print out that string matches the regular expression. Otherwise, it will print out the string does not match the regular expression. Right? Do not quote that regular expression on the right-hand side. Right? If you quote it, that turns off the meaning of the special characters inside the regular expression. Oh, it's right here. There's a big yellow box, right? So be careful when quoting the regular expression. Right? If you quote the variable, quoting the variable expansion forces the entire pattern to be matched as a plain old string instead of actually matching a regular expression. Okay, so it's very useful to either have a script like the one I'm about to show you so that you can test your regular expressions when you're writing them, or you just look online for a regular expression tester, which might be better because the online versions tell you what's wrong with your regular expression. This one's just going to tell you whether or not it matches. Right, so my script requires two arguments. Right? It requires the string that you want to know. It requires the string and the regular expression. It tests, does the string match the regular expression? Right, so string first, regular expression second. If the string matches the regular expression, then it tells you that it matches. If it doesn't, it tells you it doesn't match. Okay. All right, so what do regular expressions look like? So a simple regular expression is just a plain old string, right? That's the simplest regular expression you can have, right? So if I just write the string A, right, then what this is saying is does str, the string, does it contain the character A, right? So that looks a bit weird, right? It's not testing does it equal to A, it's testing does it contain the string A. Right? So does hello contain the string A? The answer is no, right? So hello is not matched by the regular expression A. Right? Does walrus contain the string A? Yes, walrus does have an A in it, so it matches that regular expression. Right? So if you want to test, does a string contain a character? It's pretty easy, right? Equals tilde character. and away you go. Normally, you don't want to do something that simple. Right? Okay, so what happens instead of a character, you pass in a string. Right? And so now you're asking, does that string contain that string? Right? So no, right? Hangry is not matched by and, but Sandman is because it contains the sequence A and D right there, right? So that does match. Right? So if you have a regular expression and it's just a plain old string, no special characters in it, it's basically searching, asking, does your other string contain the regular expression? And that's it. Okay, so now we're going to talk about more complicated regular expressions. So to describe the pattern that you want to match, the regular expression languages use something called meta-characters. Right? In other words, characters that have special meaning. Right? Every regular expression language is different. So this is the one that's defined by the POSIX extended regular expression syntax. Okay, so the first two are not too bad. So the first one's called the caret, right? Shift 6 on most keyboards, on most English language keyboards, sorry. That's called an anchor, right? So the caret matches the start of the line, right? When you use it as the first character of your regular expression, right? So if caret's the first character of your expression, it's saying, does your string start with something? The dollar sign, if it's used as the last character of the regular expression, says, does your string end with something? Right? So starts with, ends with. Okay, so let's look at an example. All right, so remember, regular expression, if it's just a plain old string, right, then any string that contains the sequence HELLO will match that regular expression. Okay, what about the next one? So the way to read the second regular expression is, right, starts with a caret, right? See if I can get this to highlight properly. Okay, so caret, right? And so the way to read this regular expression is, does the string start with an H, right? Or does it start with an H, right? Does it end with an O, right? And now the rest of it, those are just plain old characters, right? So this regular expression is saying, does it start with an H, and is followed by an E, and is followed by an L, and is followed by an L, and ends with an O, right? So it's not testing whether or not your string has hello in it. It's testing, is your string actually hello, right? So that's how you match an exact string, right? The caret and the dollar sign, it affects the thing that's immediately in front of it, right? So it affects, in this case, it's the character that's immediately after it. And here it's the character that's immediately in front of it. Let me just run the regular expression testing program out. What's this called? This is called test. Okay, so my string is hello, and I would like to know, does it match that thing? Right? So yes, it is. Right? If I stick anything in front of the hello, it will say it's not. Right? Because a hello does not start with an H. Right? And so that fails. So those are your anchors. Now, if you want to match, if you don't care what the character is that you're matching, but it has to match some character, right, that's the dot, right? So dot matches any single character. So let's go back to this example here. Okay, so I know that a hello does not match this thing here, right? But it does match that there, right? So starts with any single character, right? Followed by H, E, L, L, ends with O, right? So A hello matches, right? Obviously B hello should match. Oops, sorry. B, right? And this is any single character, so it could be a number. Sorry, if I could type, which can be a number, right? It can be a symbol, as long as it's not a special symbol. So, I guess. Oh, no, not. I guess exclamation mark is special. What's not special? Hyphen? Sure. There we go. Right? So any single character, right? Not necessarily a letter. Okay, now if you actually want to match a character but you care what the character is, right, you can put what those characters can be inside of square brackets. Right, so this is similar to how you would match a character in a wildcard expansion. Right, so for example, if I wanted to match a single A, B, or C, I could write square brackets A, B, C. What's the example here? Oh, I guess we have some other examples here, so this is good. Okay, so that regular expression matches anything that starts with, any string that starts with a single character and then ends, followed by an E, followed by an L, followed by an L, ends in O. Right, so all of those match. Right, starts with H, ends with O, has something, something L in between. Right, so all of those match. All right, so here's the square brackets. Right, starts with an S, ends with a T. In between, there can be an A, E, or I. Right, so that's what the square brackets mean. Right, it's a character class, matches any one of the things inside of it. Right, so sat, set, or sit are the only strings that match there. You can specify a range with the character class. Right, so A through Z means match any of the characters A through Z. Right, so that matches all the strings sat through S, Z, T. Right, if you want to match the hyphen, then it has to be either the first character or the last character in the character class. If you put it in between somewhere, it thinks it's a range. Right, so that hyphen has to be at the front or the back. So that matches S hyphen T and all of the other things that the previous regular expression matched. Right. File 0 through 9 will match file 0, file 1, file 2, up to file 9. Right. If you want to match the period, right, remember the period's a meta character. So if you want to match the period, you have to put the period inside square brackets. Right, so A, square brackets, period, C matches A dot C. Right, and so there are examples of the first, that, and the square, and the bracket expression. Right. Sometimes it's useful to say, I don't want to match a set of characters. Right, so again, you use the bracket expression, but the first character is the caret. Right, and so that'll match anything that's not inside of the square brackets, occasionally useful. This is probably a good place to stop because the next set of things are a bit complicated and will need more explanation. Right? And so yes, okay, so we're going to start talking about atoms in the next lecture. Atoms and what are the quantifiers? Right? So you can match a specified number of occurrences of something as well. Right? And so we'll pick that up at the beginning of the next lecture. And I guess that's it for today.